Hello everyone, welcome to Algebra 2. Today's lesson is on parent functions. Before we discuss parent functions, let's discuss what a family of graphs is. All right, so a family of graphs displays similar characteristics, and a parent function is basically the simplest function of the family. So the more common functions that you've come across, of course, has been linear functions, and those look like this. So f of x is equal to x. What is the domain and the range for this particular graph? Well, let's graph it. F of x is equal to x simply looks something like this, right? Whatever x is, y is the same thing. So the graph is going to look like so. Change that to blue. So for a function, a linear function f of x, the domain is all real numbers. The range is all real numbers. The x-intercept is right at the origin, so that it's at 0, 0. The y-intercept is also at the origin, 0, 0. What is the maximum number of roots or zeros? That is 1. And this will lead you way back to one of the first lessons that we covered in regards to roots and zeros. All right, so what is what's called the end behavior? Well, as x approaches infinity, f of x approaches infinity. So as this goes to the right toward infinity, y does the same toward infinity. As and then of course as x approaches negative infinity, so if I'm going in this direction to the left, f of x is going to be doing the same thing. It approaches negative infinity. We also touched on absolute value, and we did do a few of those graphs, although we haven't really done many of them. So the function for an absolute value is simply f of x is equal to the absolute value of x. It's the simplest function for this type of um, in this family. What does this look like? Well, the result is always positive. So f of x equals x would be this way. When f of x is negative x, again, we're taking the absolute value. So the absolute value of negative x is simply x. So it goes this way. So the graph for f of absolute value of f of x looks like this. Okay, so what is the domain for this? Well, the domain as far as the possible x values, if you go from negative infinity to positive infinity, there is no break, there is no gap. So the domain for f of x equals absolute value of x is all real numbers. What about the range? As we look at the y-axis, you notice there isn't anything below the x-axis. There isn't anything below 0. So the range is y is greater than or equal to 0, because at 0 it does exist. The x-intercept remains at the origin, 0, 0. Same thing for the y-intercept. Maximum number of roots and zeros, that's going to be, in this case, 2. The end behavior. So as x approaches infinity, what does x do? Well, x approaches infinity. Sorry, what does y do? So as x approaches negative infinity, what does y do? Well, it's absolute value, so that's actually still positive. Okay. Let's look at quadratic. So quadratic functions, simplest form would be f of x is equal to x squared. So what does that one look like? Well, at 0, of course, it is 0. At 1, it's still 1. At negative 1, it's 1. At 2, it's 4. 2 times 2 is 4, so 1, 2, 3, 4. At -2, it's also 4. So this one looks like not the prettiest of images. Obviously, there's a curve. So it looks something like that. The domain, again, from negative infinity to positive infinity for the x values, that one is all real numbers. As you can see, there is no gap, there is no break. When it comes to the y-axis, however, that one is y is definitely greater than or equal to 0. The x-intercept, again, this is just a parent function, so it is going to be at the origin. So 0, 0. Y-intercept, same thing, 0, 0. Maximum number of roots is going to be 2. What is this end behavior? Well, as x approaches infinity, what does f of x do? It goes to infinity. As x approaches negative infinity, what does f of x do? Once again, it approaches infinity. So these three parent functions, um, forgot to mark down that they are continuous. Again, there is no break here. Let's take a look at the cubic function. So the cubic function would be f of x is equal to x cubed. This one's a little trickier, so do your best in drawing this. But for x cubed, so at 0, it's 0. At 1, it's 1. At -1, it is -1. Right? -1 times -1 is +1 times another -1. We go back to negative. At 2, so 2 times 2 is 4. Times 2 is 8. So that one's actually off the grid here. 1, 2, 3, 4, 5. So it's going to be somewhere up here. So this one's going, so at 2, it's 8. So this looks something like, man, that's messy. More like this. Okay, domain and range. Same, all real numbers. So we're doing this so you can have a note set up for what these types of functions should look like. Okay, so this is a great reference tool for later. The intercept and the x-intercept and the y-intercept are at the origin. So let's just mark 0, 0, 0, 0. Now this one, the maximum number of roots are 0, it's x cubed. So we're looking at 3 roots. What does the end behavior look like? Well, as x approaches infinity, f of x goes to positive infinity. As x approaches negative infinity, f of x goes to negative infinity. And this one, of course, is continuous. Feel free to pause and finish writing these in your journal. Next up is the square root. I'm sure you've seen these before, but you may not recall uh, what the graph looks like, right? So the square root, what is that? Well, f of x is equal to the square root of x. At 0, it's 0. At 1, it is 1. Let's see. Well, I know at 4 is going to be 2, right? So 1, 2, 3, 4. Y is 2. Square root of 4 is 2. So this one looks like this. And of course, we cannot take a square root of a negative number, so there's that. So we have the domain. If you notice, the domain is only exists from 0 to positive infinity. So the domain in this case is x greater than or equal to 0. And the range is also on the positive end, so y is greater than or equal to 0. Once again, the x and y intercepts are at the origin, so that's 0, 0. Maximum number of roots, so only 1. All right, so end behavior. So as x approaches infinity, f of x goes towards positive infinity. As x approaches 0, y approaches, or f of x approaches 0, right? This is where it is. And this one is definitely not continuous, so we'll mark it discontinuous. Let's take a look at the cube root. So the cube root is f of x is equal to the cube root of x. What does that one look like? So at 0, it is 0. At 1 is 1. At -1, it is -1. So this looks like something like this. Okay, as you can see from the left to right on the x-axis, there is no break there. So this is all real numbers. For the range, it's going to rise very slowly, but it is also all real numbers. The x and y intercepts are again at the origin, and you're going to see that basically with most of these parent functions for the reason that it is the um, simplest function in the respective families. So cube root, what else do we need? We're looking at the number of roots and zeros. So for the cube root, that's going to be 1. The end behavior as x approaches infinity, f of x goes towards positive infinity. And then as x approaches negative infinity, f of x goes towards, well, negative infinity. Let's talk about the reciprocal. These are interesting. So the reciprocal is the f of x is equal to 1 over x. And how do we graph that? Well, we know that 1 over 1 is 1. There is nothing at the origin. All right. Let's see. So then at 2, what is this going to be? 1 over 2, that's 1/2. So at 2 is going to be about right here. And at -2, going to be the same thing. So add -2, we get 1/2. But what do we get at 1/2? So at 1/2, 1 over 1/2, it's actually 2. Or sorry, this is -1/2, -2. For 1/2, it's going to be at 2. So this gives us a great idea as to what to expect for this particular function. And it's going to go like this. Whoops. There we go. So it doesn't quite get to 0. Okay, there you go. So let's take a look at the domain and range. So the domain for a reciprocal for all values of x, x is not 0 or not equal to 0. What about the range? Same thing. For all values of y, y does not equal 0. The x and y intercept, well, they never get there. So there is no x or y intercept. Maximum number of roots of zeros is 1. The end behavior, well, as x goes towards infinity, f of x approaches 0. As x approaches negative infinity, f of x will approach 0, but never quite get there. Once again, this will be discontinuous, but now we look at something called asymptotes. So the asymptotes for a reciprocal, and this one we got x is equal to 0, y is equal to 0. Let's take a look at exponential. So exponential functions, what are those? Well, f of x, whoops. So f of x is equal to 2 to the x. 2 to the x. What does that look like? All right. Well, 2 to the 0 power is 1. Well, anything to the 0 power is 1. 2 to the 1 power is 2. 2 to the negative um, 2 to the negative 1 power is, what is that? 2 to the 1 is 2. 2 to the negative 1. Why am I drawing a blank? Let's take a look. So we're going to have 2 to the negative 1. It's 1/2. Oh. So 2 to the negative 1 is 1/2. So negative 1, 1/2. All right. So the exponential function, that's going to not quite get to 0. And then just skyrocket. Okay, so as far as the domain, x values, that is all real numbers. But as far as the range, well, this is greater than 0, but does not get to 0. Okay, so the x-intercept, it is not going to cross the x-intercept because it does not actually get to 0, so not applicable. But the y-intercept, well, in this situation, we got the 0, 1, right? This, of course, is, well, I was going to fill out another portion of this, but let's wait on that. The maximum number of root zeros is 1, and then as x approaches positive infinity, f of x is positive infinity. As x approaches negative infinity, f of x is 0. And this one is actually continuous. The asymptotes are at 0, so y is equal to 0. It's okay if you don't fully understand what I'm writing down. Will be used as reference as we proceed and cover all of these parent functions. One more. Let's look at logarithmic functions. So logarithmic functions, f of x is equal to log x. So f of x is equal to log x. And that one, it's a bit strange, but it's going to look something like this. Okay. So x is greater than 0, so that's my domain. My range is all real numbers. The x-intercept is 1, 0, and the y-intercept is none. It doesn't quite get to the y-axis. Maximum number of root zeros is 1, and behavior as x approaches infinity, f of x approaches infinity. As x approaches 0, f of x approaches. See how it's going all the way down? Well, it's negative infinity. This one is continuous, and the asymptote is at x equals 0. So make sure you have these handy. The notes themselves, the guided notes will be posted on Google Classroom, so you should have those. And please watch this video to complete. You should have them complete once you've watched this video. Feel free to go back, pause as much as you need to make sure that you have these handy as we move on and covering each of these parent functions. All right, thank you. Have a good day. We'll see you soon.